So we'll do some parallel demo circuits here. And we'll do the math right on the calculator so that we can make sure we're getting the right values. As with the other ones, the first thing you want to do is fill in all of your known values. So we're given our resistor values, R1, 2, and 3, so we want to write those in. R1 is 1.5K. R2 is 5.1K. And R3 is 2K. We want to make sure we're using the K and the engineering exponent. So we're going to add up and get that total resistance. So our first resistor is 1.5K ohms, 1.5 second EE3. So that's the 1.5K. So now we're going to hit the x to the negative 1 key. I know it's a lot of keys to keep track of, but it's going to do the math for us. We just have to keep track of everything. So let me write that formula here. 1 over R1 plus R2 plus 1 over R3. So we just entered this first part and the plus sign, so now we're going to do 1 over R2. Our second one is 5.1 second EE3, and then we have to hit x to the negative 1 because we want the reciprocal. Then we hit plus again, and R3 is 2K, 2 second EE3, x to the negative 1. Now when I hit equals, I've got the bottom half, but I still have to get the reciprocal of that. And you'll notice the number's less than 1. It's 1 point whatever times 10 to the negative third. Well, we know our total resistance isn't going to be less than 1. So if you ever get that or you get something really, really weird, so we have to just take this and we hit x to the negative 1 to get the reciprocal of that, and we get 733.8 ohms. And is that less than 2K ohms? You bet. So we can be pretty confident that our total resistance is good. It's a good ballpark figure. So now we also know our total voltage. I didn't write that in when I put in the other given values. What do we know about the voltage in the branches of a parallel circuit? Stays the same. So we're going to have this same voltage on all three of these resistors. So we've got all our resistances, we've got all of our voltages. So now we want to find the current in each resistor. So current is voltage divided by resistance. So for the first one, I'll write the first one on paper. 42 volts divided by 1.5K ohms. 42 volts divided by 1.5 second EE3 for 1.5K ohms. And that gives me 28 milliamps. Sounds about right. R2 is 5.1K, so I'm going to start. So now I won't write the rest of them, but I'm going to have 42 volts, and I'm going to divide that by 5.1 second EE3, and I get 8.23 milliamps. And my third resistor, I've got 42 volts, and I'm going to divide that by 2 second EE3, and I get 21 milliamps. So now, for my total, I can just take the total voltage and total resistance to find my total current. IT equals ET divided by RT. So I take my same 42 volts divided by 733.8 ohms. And I get 57.2. So on my drawing here, R1 has 28 milliamps. R2 has 8.23 milliamps. And R3 has 21 milliamps. So my total, when these three currents combine together, is just going to be these three added together. So I can double check my math here, and I can go 28 milliamps plus 8.23 milliamps plus 21 second EE minus 3 for milliamps. And I get 57.23 milliamps. So I can double check these numbers because these three currents should add up to the total. Now it looks weird because we think if I'm taking 42 volts dividing by each individual resistor, how can I take 42 volts and divide it by the total resistance? It's kind of weird in our head. And again, we don't have to study it, we don't have to worry about it, but this is where those conductances come in. That's where that inverse formula does kind of help us make sense of it. But it works. And if you do a circuit and those numbers don't add up, if those currents don't add up to the total, something's wrong. Use these two functions. By adding these up, you can check that answer and know your answers are correct. And then you can take your voltage and divide it by that current and check that total resistance, and then you know your answers are correct because you want to have correct answers. You don't want to just hope they're right. So the power is pretty straightforward. P equals I times E. So we just take our current times voltage. Somebody multiply that first one for me. 1.18 watts. So go ahead and take 42 volts times 8.23 milliamps. And we'll see what we get for watts on that second one there. Well, let's see. We've got 42. So we've got 42 volts times 8.23 milliamps. So it's going to be second EE minus 3. So it should look just like that. Yep, 345 times 10 to the negative third. So that's 345.6 milliwatts. 345.6 milliwatts. Matt, you got the third one? 882 milliwatts. So now we can add these three up to get our total, and then we can multiply across to get our total, and they should be the same. So if I take 1.18 plus 345.6 second EE minus 3 plus 882 second EE negative 3 equals 2.4 watts. Sounds about right. So if we take 42 volts times 57.23 second EE negative 3, we get 2.4 watts by multiplying across as well. So we can be confident. Our numbers are good. We know everything we're going to need to know about this circuit. If we needed to measure something, we'd be able to know exactly what it should be. And that's what you'll be doing with the labs. So we'll get a little practice in the labs, as well as I'll give you a homework assignment. It'll be on paper. It won't be on Blackboard. But the second one trips us up a little bit. This is saying we know R1 is 20 volts, and we know our total resistance is 631.6 ohms, but nothing else. And we think, well, can't be done. Throw in the towel. It's all over. Well, if I know the voltage on this branch, what do I know about the other branch voltages as well as the total voltage? They're all the same. So I can fill this in. I'm going to fill in my known resistance values. R1 is 1 k ohms. R2 is the one we don't know. And R3 is 3 k ohms. We know the voltage and resistance of R1 and R3 and of our total, so let's go ahead and fill those in. Anybody got the first one yet? 20 volts divided by 1K is 20 milliamps, you bet. So now we can't do R2 yet, but Matt, you got R3? 6.66 milliamps or 6.7. And we can find our total, 31.6 milliamps. So now that we know these three need to add up to the total, so when we add up these two, 20 milli plus 6.6 milli, we get 26.6 milliamps. So that's how much current is being used up by branches 1 and 3. And we know we have a total of 31.6 milliamps. And if these two, I'll write them in real quick, 20 milliamps and 6.66 milliamps, have a combined 26.6 milliamps, we can just subtract that from the total. If I don't worry about that last column, I can do this one in my head. Five milliamps. I can find the resistance of R2, trying to fit my calculator in there somewhere. I can find the resistance of R2 by using my voltage and current. So I will have 20 volts divided by 5 milliamps, second E negative 3, equals 4 k ohms of resistance. So now, this is where, to make sure we've got all our answers right, because one thing that's well, neither good nor bad with assignments on Blackboard, when you enter them numbers, they're entered. I mean, you can go back, you can backtrack, but once you hit submit, you want to make sure all your numbers are right. So I can use my inverse reciprocal formula. I can use my inverse reciprocal formula and double check that these three, I can find that these three resistances in parallel is indeed 631.6 ohms. So let's punch that in, and I'll just do it silently while you punch so I don't mess up. And my numbers check. Are yours checking? I see the buttons going. Getting it okay? All right. So, then the last is power, and that one's, like I always say, that one's easy as pie. So, anybody got any of the powers yet? 400 milliwatts, 100 milliwatts. All right. 631 milliwatts, and then 4, 5, 6, 632. They add up to within a milliwatt, so that's more than close enough. So we've got the whole thing solved, and you know, just keep track of what you're doing on the calculator there. For the homework, I know you already did some review questions on Blackboard, but these practice problems, they're charts real similar to mine. Theirs are just set up different. So with their chart, I put the totals on the bottom. They put all their totals on the left. So then, you know, like this is our everything to do with R1, R2, R3, and R4. So these are all a circuit with 4 parallel resistors. But just like we did, here the first one, they're giving you all the resistor values, just like we did. And then the second one, they break it up a little bit. They give you the current for these 3 and the total, but they give you the power here. That is page 171. Now you don't have to turn these practice problems in, but you are expected to do them and to be able to solve them. The answers to these are in the back of the book. If you should happen to fail the quiz, you will be expected to produce this to show you that you've either studied or reviewed this material. You can make your own chart. However, you can lay it out like theirs if you want, either way. Thank you.